Assalamualaikum and hi everybody. See you again in this video. So in this video we will discuss about the structural question that relate to the deformation of solid. For question number 1A, a wire originally 2 meter long suffers a 0.1% strain. We need to calculate the final length of this wire. So for the solution, 0.1% strain is equal to 1 times 10 power of negative 3. So first step, we need to calculate the elongation of the wire, and then we calculate the final length, which is equal to 2.002 meter. For question number 1B, a length of copper of square cross-section measuring 1 mm by 1 mm is stretched by a tension of 40 Newton. What is the stress in Pascal? So to calculate the stress, we use the equation of F over A. We substitute the value and we get the stress which is equal to 4 times 10 power of 7 Pascal. For question number 2, a piece of bone under tension and compression is as shown in the graph. Which portion of the graph shows that the bone is brittle? So, if you refer to the graph, bone brittle shows at the breaking point. Because of that, for the compression, the breaking point is when stress is equal to 2 times 10 power of 7 Pascal. And for tension, the bone brittle when the stress is 3.5 times 10 power of 7 Pascal. For question 2b, from the graph, calculate the Young modulus for bone under condition of compression and tension respectively. So, to calculate the Young modulus, we use the Young modulus equation which is equal to stress over strain, and we substitute the value for compression, we substitute the value stress and strain at the compression, and same thing for the tension. Because of that, we get the Young modulus for compression is 1 times 10 power of 9 Pascal, and for the tension, it is equal to 1.75 times 10 power of 9 Pascal. For question number 3, the force against elongation graph for wire X and wire Y are as shown. We need to calculate the work done to extend wire X and wire Y by 1.5 mm, and we need to state which wire is more rigid. From the information given, the original length and the cross-section area of the wire are equal. So, to calculate the work done, we will use the equation of half Fe. We will get that the work done on the wire X is equal to 0.225 joule and wire Y is 0.141 joule. Because of that, wire Y more rigid. For question 3b, we want to calculate the ratio of the Young modulus of wire X to the Young modulus of wire Y. So, we will use the value where the elongation or the extension of the wire is equal. Because of that, we get that the Young modulus is directly proportional to the force exerted on the wire. So, from our calculation, we get the ratio of Young modulus of wire X to the Young modulus wire Y, which is equal to 1.6. For question number 4, a brass wire 2.5 meter long of cross-section area of 1 times 10 power of negative 3 cm square is stretched 1 mm by a load of 0.4 kg. First, we need to calculate the Young modulus for the brass. To calculate the Young modulus, we use the Young modulus equation which is equal to F L naught over AE. We substitute the value in the equation and we get the Young modulus which is equal to 9.81 times 10 power of 10 Newton per meter square. For question number 4b, what percentage strain does the wire suffer? So to calculate the percentage of strain, first we need to calculate the strain. So strain is equal to E over L naught. We substitute the value, we get the strain which is equal to 4 times 10 power of negative 4. And then to calculate the percentage, it is equal to 0.04%. For question number 4c, we need to use the value of Y to calculate the force required to produce 4% strain in the same wire. So, for the solution, actually 4% strain is equal to 0.04. From the Young modulus equation, which is equal to F over AE, we rearrange because we want to calculate the force. We substitute the value and we will get that the force required to produce 4% strain is equal to 392.4 Newton. For question number 5, There are two wires, which is wire X with a length of 100 cm and diameter 2 mm and wire Y with a length of 200 cm and diameter 4 mm. Forces exerted on both wires and the extension for each wire produced are 0.1 mm and 0.04 mm respectively. We need to determine the ratio of the young modulus for wire X to the wire Y. So take a look at the information given and the hidden information. So referring to the diameter, we get the hidden information, which is the cross-section area. We use the young modulus equation where we substitute the A2, and then when we cancel the equal value between the wire X and wire Y, we get the final equation, and then we substitute the value. Do take note that I not change the unit because of each unit can cancel each other. So finally, when we calculate, we get that the ratio of the young modulus for wire X is to the wire Y is equal to 0.8. That's it for the part 2. See you again in the next video for the part 3, discussion of structural question for deformation of solid topic. Please show your support by clicking the button subscribe, like and share, and leave a few comments so that I can improve my video and I can produce more video for all of you. Thank you very much and I wish you all the best.